I welcome you all in this presentation related with the subject fundamentals of the surface engineering, and we are talking about the various surface damages which adversely affect the performance of the component. And as we have talked that there are few wear mechanisms through which most of the material loss take place and causes the damage to the surface, and which in turn leads to the reduction in performance of the component. And these mechanisms are like adhesive wear, abrasive wear and corrosive wear. So, these three mechanisms account for about 80 to 85% of the loss of the material from the functional surfaces, while the remaining loss is caused by other mechanisms of the wear. Now, we have also talked about the few basics related with the adhesive wear, and today we will be talking about the various mechanisms which are involved in adhesive wear. So, for understanding the adhesive wear and related aspects, it is important to understand that any wear system forms a tribological system, which is called tribo system. What tribo system includes? Like one matting component, this component 1, and there is another component which is basically component number 2. This may be considered as a counter surface also. Then these two components will be matting and interacting in certain environment, and these components will be working under matting and working under some kind of the loading, either because of their own weight or externally applied load. So, there is some kind of the loading, and whenever there is a movement of one component with respect to another, there is a relative movement that is called relative velocity or sliding velocity, depending upon the kind of configuration. And whenever there is a relative movement, some work is done, and that work, frictional work, gets converted into the heat. So, some kind of the heat is also generated. So, if we see these are the different constituents of any system where we have the load which is being transferred with, it may be externally applied load, or it may be due to the weight of the component's own weight. Then the relative velocity or the sliding speed of the component. Then the environment in which this interaction is taking place, this is also another big factor. So, this is third component. Then these the matting components which are involved, obviously these will be the 2 in numbers, and there can be more, like in abrasive wear conditions, between these two, between any two components, third particle also appears. So that forms the third body, but that happens in case of the abrasive wear. Although in adhesive wear also, whenever wear particle is removed from one of the surfaces, then its presence also can act as a third body. So, these are the important aspects related with. Then one of these component is termed as counter surface, and the one component is may be termed as the component which is sliding over the another. So, one will be harder or softer than the other. Normally, both are not made of the same type of the material, so that they have same crystal structure, properties and the hardness, but it is always preferred that the two are different with regard to the materials, with regard to their hardness. And this plays an important role in controlling the wear and having very reduced rate of the wear. So, this as a whole is termed as the tribological system. Now, environment in which the sliding is taking place, this can vary significantly, like this sliding may happen under the dry condition, or it may happen in the well lubricated conditions for controlled wear, or it can be under the semi lubricated conditions. So, likewise, and accordingly our the wear rate or the loss of the material from the functional surfaces will be affected. Now, if we see there are for the adhesive wear, there has to be a direct metal to metal contact between the interacting surfaces, and under such conditions, whenever there is a loss of material from the interacting surfaces, then as per the load and the sliding speed conditions and the frictional heat conditions which is generated, there can be the loss of material from the interacting surfaces through these three basic mechanisms. These basic mechanisms are like adhesion, then deformation and fracture, and third is frictional heating. All these three may be involved actually in any kind of the sliding conditions, but their relative contribution on the material losses may vary significantly. Normally, simple adhesion is the way by which the material is removed from the functional surfaces under simple adhesive wear conditions, or under the scissor like conditions. The deformation and the fracture are involved under the conditions of the surface fatigue wear and fretting wear, and the frictional heating plays a big role in melting wear and the diffusion wear. So, these are the three broad categories of the fundamental mechanisms involved in the adhesive wear, and as we have seen in all these cases, the kind of the direct metal to metal contact which exists, that governs the frictional force generated during the relative movement, or the frictional resistance which has to be overcome during the to maintain the sliding, and the wear or the material loss from the functional surfaces. That these two aspects are governed by the kind of the direct metal to metal contact which exists between the matting component, and this direct metal to metal contact, whenever it exists, it happens through these three mechanisms. One is like mechanical interlocking, and the second is electron exchange or free electron exchange, and the third is the diffusion. Third is the diffusion across the interface, because most of the time metals are different, their compositions are different, and the energy levels of the two sides are different. So, the diffusion is also facilitated. What is important, since all surfaces have surface regularities, so the contact exists at very localized points where true stresses are very high. So, the surface layer deformation takes place, which leads to the mechanical interlocking. Greater is the mechanical interlocking, greater will be the force with which two components will be holding together, and accordingly it will require greater force to maintain the relative movement. So, the frictional forces will be high when it has greater mechanical interlocking. Similarly, the electron exchange is the another mechanism. Whenever two comes in contact with each other, the free electrons move from one side to another and forms the bond between the two components. So, if one side has a metallic matrix and another side it is non-metallic constituents, then this kind of transfer is not that much facilitated. So, it is always good to have this situation where in two metals, out of the two metals, they are reinforced with the non-metallic constituents. So, wherever the non-metallic constituents are present, such kind of the free electron exchange will not be possible across the interface. So, the bond formation tendency is reduced. The third mechanism is the diffusion, which also facilitates the bonding between the matching components. So, wherever the direct contact exists, the diffusion starts due to the compositional gradient across the interface, and that in turn leads to the or facilitates the formation of the bond between the two matching components. So, if there is a very general principle that if greater area between the two matching components comes under the cold bond or the metallurgical bond, or the bonding is created between the two over a larger area, it will increase the frictional force. At the same time, it will also increase the wear volume. So, all those factors which will be discouraging the mechanical interlocking, free electron exchange and the diffusion, then it will be helping to reduce the friction coefficient as well as the wear loss from the functional surfaces. So, what is the most common approach to have this one is that if the two matching components are isolated from each other in such a way neither mechanical interlocking nor the free electron exchange and diffusion is facilitated. And for this purpose, under the actual working conditions, one common thing which is facilitated is the use of lubricant between the two components. So, the two components will not be in direct metal to metal contact, but contact will be existing through the some kind of the lubrication, and this will resist significantly the mechanical interlocking, free electron exchange and the diffusion, and which in turn will help in reducing the friction as well as wear. But so this will be the situation where the good lubrication exists between the matching components, but if there is a loss of lubrication or if the sliding is taking place under the dry conditions, then certainly all these phenomena will be present. So, now we need to see what are the factors which affect this bonding, which in turn determine the frictional force and determine the way by which material loss from the functional surfaces which will be taking place. So, there are two broad categories, although there are large number of the factors which affecting the adhesive wear. Broadly, there are two categories. One is the service condition related factors and another is the material related factor. Material related factors. So, material means the material which is being considered from the wear point of view, and the service conditions related factors. So, under the service condition related factors, we have the normal load, the loading conditions under which sliding has to take place, and the relative velocity of the matching component, which is another important aspect. Then environment in which sliding is taking place, whether it is dry or it is lubricated, it is vacuum or it is inert atmosphere. So, accordingly the kind of the interfacial interactions and the metallic intimacy between the matting components will be affected. And these factors, so apart from these factors, we have the another matting component against which rubbing is taking place, which is termed as counter surface. Counter surface material, its hardness and its temperature. These are the three important aspects that affect the kind of the metallic intimacy, the way by which material loss and the frictional effect which will be offered by the component which is being considered. On the other hand, in the material side, we have the material which is being considered from the wear and friction point of view is its surface roughness. So, this is one parameter. Then its hardness, then percentage elongation or the ductility of the material, its work hardening tendency, then complexity of the microstructure, then its crystal structure, then stacking fault energy, So, this is these are some of the material related aspects. In addition to this, we have the presence of non-metallic constituents or particles present in the metallic matrix, like presence of oxides, nitrides or ceramics. So, these will be reducing the free electron exchange across the interface, and which in turn will help in reducing the bonding. So, now we will see their role at length one by one, but before going into that, we need to see what happens. These factors of course will be considered with regard to the way by which wear of the material takes place. So, if we have to go through one by one about these factors, but before that, what we will see that if we take one component and it is under controlled conditions, it is subjected to the wear test or sliding wear test, then we will be able to measure the way by which wear or the material loss from the functional surfaces from this test piece is taking place, and this is the counter surface. So, under given load conditions and given sliding speed conditions, and for a sliding over a given distance, what is the wear or the loss of material from the functional surface, which may be measured in terms of the volume loss or in terms of the weight loss. So, weight loss is generally a common method which is used for calculating the wear. So, weight loss divided by the density, that gives us the wear volume. Wear volume is commonly used method for expressing the wear or the material loss from the functional surfaces. So, as a function of time, means if the sliding continues for longer period over a longer distances, and then we try to see the way by which the wear or the material loss from the functional surface is taking place, say in mm³, and as a function of the sliding time, or for a given sliding speed there will be a sliding distance. So, of course, it will be for given speed of sliding. So, if we see the way by which the wear volume changes as a function of time, what we normally notice, initially there is a sharp increase in the wear volume and then it becomes constant like this. So, what it shows, initially the wear continuously changes, wear volume or the material loss from the functional surfaces continuously changes as a function of sliding time or the sliding distance. So, the period in which there is a continuous change in the slope of the curve, that period, the distance over which, distance up to which from the start of sliding to the period up to which there is a continuous change in the rate at which wear is taking place, which we can see from the slope of the curve, because this curve is basically the wear volume and the sliding distance or sliding time. So, if this curve is straight, which will show that the wear volume is linearly related with the sliding distance, but it does not happen actually. The wear volume initially it is high, the rate at which the material loss takes place is high, and then it keeps on decreasing and then it becomes constant. So, the distance or the time up to which there is a continuous decreasing wear volume as a function of time, that is termed as a run in period. And thereafter the relationship between the wear and the sliding distance or sliding time becomes constant for a given sliding speed. So, this is termed as steady state wear. So, steady state wear is normally used for the comparison purpose, and if we see why there is a change in the wear in the initial stage of the sliding. So, for understanding this, what we say that in the initial stages, conditioning of sliding interfaces takes place. Like say the both the surfaces are fresh, so they are clean and they have their own roughnesses, they have their own hardness, crystal structure, they have their own composition. But whenever the two starts interacting with each other, the surface roughness will change. Due to the interaction, frictional heat is generated, so oxides are formed at the interacting surfaces. So, here oxide layers will be formed on the both the sides of the components, and there will be continuous exchange of the constituents from one side to another. So, we can say metal transfer takes place across the interface. So, there is a continuous change in the composition, roughness and the cleanliness, because oxides are formed, even because of the change in composition, crystal structure, because the structure is damaged, the grain size, everything is modified during the sliding, and because of which hardness also changes. And these things will be happening very fast in the initial stage of the sliding, that is termed as run in period. And once this kind of conditioning of the sliding interfaces completes, thereafter it attains the steady state of the wear. So, normally this steady state of the wear is used for the comparison purpose, or the way by which the material loss from the to understand the kind of resistance it offers to the loss of the material, because during the run in period itself, if we see one material may show this trend in this way and another material may show completely different trend, wherein for one material slope is like this, for another material slope is lower, for third material slope may be further lower. So, basically this slope shows the wear volume versus the distance relationship, which is termed as wear rate. So, slope of the curve in wear versus the sliding distance or the sliding time curve for a given sliding velocity, it shows the wear rate. So, the slope of the curve basically shows the wear rate. So, if the slope is high, wear rate will be high. The materials are selected in such a way that whatever is the wear rate under the control conditions of the sliding, that wear rate is able to complete the expected life of the component. If the wear rate is too high, then it will be losing the dimensions and shape much earlier, and it will be leading to the failure much earlier. So, it is important that most of the tribological systems are designed, most of the tribo systems are designed to perform under the mild wear conditions. What these mild wear conditions means? The load, the velocity of the matting component during the sliding, the lubrication, the environment means counter surface or the matting components. All these are such that the wear rate is very low, and the loss of the material is primarily taking place through the oxidation, and it is very gradual loss of material from the functional surfaces. So, under the mild wear conditions, the load, velocity, lubrication, environment, all these are favorable in such a way that the loss of material from the functional surfaces primarily takes place by the mechanism of the oxidation of the surfaces, oxidation of the interacting surfaces, and then the removal of these oxides leads to the loss of material from the functional surfaces in form of the oxides. So, if these oxides are very coherent, non-porous and stable, then this will be resulting in very low wear rate. On the other hand, if it is non-coherent, non-adherent, means it is very loose and porous and weak in terms of the stability, then it will be dislodged. Such kind of oxides which are being formed between the interacting surfaces, they will be dislodged very rapidly from the functional surfaces. So, they will be offering the higher wear rate or the higher rate at which material loss will be taking place from the functional surfaces even under the mild oxidative wear conditions. So, depending upon the kind of oxides which are being formed at the surfaces, that will also be affecting the rate at which material loss from the functional surfaces under the mild wear conditions which will be taking place. Now, I will summarize this presentation. In this presentation, basically I have talked about the basic mechanisms of the adhesive wear and what are the different factors that affect the adhesive wear of the material. Thank you for your attention.